One on the worksheet of manipulating vectors with trigonometry. The plate is dropped straight downward and it breaks on the floor. This is the top view. It's falling straight down into the page, shatters into three pieces. One of the pieces has a momentum of 600 gram meters per second this way. Another one has a momentum of 400 gram meters per second this way, 40 degrees below the horizontal. What's the direction of the velocity of the third piece? It's going to be something like this because the momentum before is zero and it has to be zero afterwards. But let's start. Draw a coordinate system, x, y axes, label the angle and the two known momentum. 600 gram meters per second straight along the positive y-axis, 400 gram meters per second, 40 degrees below the positive x-axis. Now we're going to get the components of this momentum. That we know is 600 along the y. How much of this is x and how much of this is y? That's what trigonometry is for. 400 gram meters per second cosine 40 degrees is the x component. And the y component is 400 gram meters per second sine 40 degrees because sine is the opposite. And that's negative because it's downwards. So now we're going to replace this vector with its components. That's why we do it. It makes it easy for us. Now we can think about conservation of momentum. The plate has zero total momentum before. It's got to have zero after in both the x and the y direction. Momentum's a vector. So we're going to conserve momentum one direction at a time, starting with the x direction. The initial momentum is zero. The final momentum is zero in the x direction. The large shard is pure y. This guy has 346 gram meters per second to the right. In order for there to be no momentum, the other piece has to have a momentum of 346 gram meters per second to the left. Let's put that on the diagram. Now we can see there's no momentum in the x direction. Now we do the y direction. A little bit more complicated. We have 600 gram meters per second up, and this guy is 257 gram meters per second down. And the total is zero. These two have a total momentum of 343 gram meters per second upwards. So this guy's got to have 343 gram meters per second downward. Let's put this on the diagram. Now, hopefully, it's easier to see that there's no momentum in that system, just as there is no momentum before. Now we have to get the direction of this piece. Which way is this piece moving? So let's focus only on the third piece. That's all that matters. Get rid of everything else. And let's make it bigger. Okay. And let's put in the momentum vector, which is in the same direction as the velocity vector. There it is. And let's define the angle of the momentum vector as the angle below the negative x-axis right here, theta. That angle we're going to get. The opposite side to this angle is the 343. That's right here. The adjacent side is 346, and we can use tangent. Tangent of theta is the opposite over the adjacent, 343 over 346. That's about 0.99. Now we can take the arctangent of both sides. The angle whose tangent is 0.99 is about 45 degrees. So we have the answer. 45 degrees below the negative horizontal axis. If you have a good diagram with get your components, you can see what's going on. It makes it a lot easier.